Welcome everyone. This is Amir Rahman, your TA for the course Applied Electromagnetics ECE351 for this semester. And I believe you have a great tutorial on another software called CST. And today we would like to introduce you a different software called HFSS, which stands for High Frequency Structure Simulator, developed by a company called ECE. Although you will be using CST a lot for the whole semester, however, getting to know about some basics on HFSS that will be really handy for you. Although we are not having pretty detailed things on this software, except just the basic tutorials, but that would be really handy for you if any one of you. I mean, considering that CST and HFSS are two most exclusively used software in the field of RF designs, that would be great to know some basics about both of the softwares. If you are thinking of doing some research and higher studies in this field, or even building up the career, so getting to know both of the software that would be great advantage for you. So one thing I like to mention here about today's lab is that this tutorial is pretty much self-explanatory, and very much detailed. So nothing much to show here because it's just everything that you can find in the tutorial itself. However, we will have a kind of quick overlook, just in case if you are stuck. Just feel free to email me. So we are having a very basic tutorial we'd like to show, and you get some similarities. That is what you have done in CST. Sometimes a little bit of different things. However, fundamentally both of the software are for the similar applications. They run on similar techniques. Okay, so to start with, I'm assuming that you have already installed the software in your computer, and if you have done that correctly, if you go to desktop, you see that EDT icon. Just click on that thing. Just one thing to know here, one thing to let you know that remember, we might have different versions from computers to computers, so there could be a little bit of differences in the interactions and interfaces, but well, you don't have to really worry about those differences because more or less they're same. And so even though if you are not finding any things after following the tutorial, again I'm saying that you can email me anytime and I'll be glad to reply. So I'm pretty much lenient on that thing, and I would welcome you to send any emails if you are having any problems. Okay, so yeah, where I was is that after clicking on that thing, this EDT is a very broad umbrella, and there are some different softwares as well. However, we are interested in this HFSS. So please click on that thing. That is something I'd like to show here. Sometimes it's confusing because some people are looking for just HFSS. No, this is under this ECE electronic desktop. Okay, so once you open there, click on the HFSS. Okay, so okay, well, it's pretty simple. If you want some help, you can get some help here. That's the very similar case for any software. And so what we will be covering, what the tutorial will be covering is that definitely the familiarization with the software. We will play with some different shapes and objects, just though we have done in the case of CST. Same for coordinate systems uh, and operations on created objects. For example, you have done already those mirroring, scaling, copying the things, flipping the things, and also there's some operations called Boolean, yeah, um, for through which you can unite the things, separate the things, separate from object to between these, I mean, create some separation from between the objects and so on. And then we'll have a look at the boundary creation, also the solution setup. Don't get confused. That is what you call solver setup in the case of CST. So let's move on. Some introductory discussion. You don't have to really look into those things pretty much. It's just the application area. It can be used in any field, most of the fields, such as fluid mechanics, mechanical engineering things, excuse me, electromagnetics from ranging from low frequency to very high frequency, structural designs, high speed structural designs, and many more. So our application here would be just this, and which is electromagnetics, just to let you know. Okay. One of the very obvious difference from CST is that it's mesh setup. In the case of CST, normally what you have done, most of the simulations we have done um, were in time domain things. Um, we have tried a little bit on frequency setup, frequency domain as well. However, uh, basically those setup differs in the terms of mesh setup. So here, this software actually uses a mesh setup called adaptive mesh refinement, um, which can give you a pretty accurate simulated result and from your simulated design, which is one of the advantages of HFSS. Okay, um, and I hope you understand what meshes are or what mesh is. This is something that, just imagine that you are having a big block where you have to uh, simulate that big block of design, but it's really hard to simulate the whole design altogether. So what the software does is that it just creates some small and tiny blocks, divide the whole things, and it runs the calculations, okay, for each and individual blocks, and then it sums up. This is a little bit of simpler process for the software, okay. So how the meshes are pretty much fine, small, that means you are getting the more accurate result, okay. um, that is something about it. That is just a glimpse of the mesh things, okay. All right. So as usual, well, as I said that I really don't have to show these things because those things are pretty much clearly mentioned here. Don't worry about this version number, which is 2019, where we are using 2022 or 23. I'm not pretty sure about that, but that doesn't really matter. And as I said, that we have already opened up the things, which is electronic desktop. So this is just all about going through the things. It's pretty easy to follow. And well, we have to we have to do some initial setups before you software. For example, we just created the file. If you want to save a new, if you want to create a new file, just create the new file, and you have to save the things, and you have to do some solution setup. Uh, for example, here, go to HFSS. There's the solution setup, solution type. Now, there's the eigenmark. Remember, you had in the case of CST, you had solver setup. Okay, um, so this is pretty much equivalent thing here. Just keep as it is. You don't have to change anything. Then, if you want to change the units, you can go to modular. As I said that, even I'm just going through and following the thing, so it's pretty easy to follow. So yeah, that's the unit, and you don't have to change a lot of units, just this. Okay, so that's fine. We're done. So those are defaults. You don't have to really look into the very very detailed things. Just follow. Then if you wanna then boundary assignments, then there are some more things to check here. For example, if you wanna go to tools, then options, general options. The tutorial is telling you to make sure that there are some things to be really, I mean, for example, I mean, what my recommendation is that don't change anything, okay? Those things are already default. So just don't mess up the things here. Just keep as it is. That is because we have checked already. But if you want to make sure that you are going in the right direction, maybe you can just follow the direction here, follow the dialog box, and just check if those things are checked. Okay, if you don't find anything not checked, just check on those things. That's it. Okay, so yeah, so let's start drawing something. um, as I said that you have done that in CST already. Okay, I think although it says here from the drawing box, but I prefer going from here. You see here all the drawing tools, just pretty similar to CST, and cylinder, box, draw a sphere, and other things, a line, so anything you can like. So if you just click on the box, well, here you see as you hover the mouse in the workspace, you can see here as you change the point, uh, you see the XYZ values are changing. So that means you know where you are actually. So for example, if you want to start from here, which is 000, the origin, apologize, here, start, just the same as CST. Okay, and we'll come up with some boxes here. Uh, you see the position here because we have started it from there. That's the X, Y, and Z side. That means the dimension of the break. Uh, well, two things here actually. You can see here, which is different from CST. One thing is command, and another one is attribute. Okay, so command means this is all about the parameters. Okay, um, and this is global means we were coming to that soon. And then attribute means if you want to name the box, just name it. If you want to assign a different material here, you can. What are the things, for example, if you want to search for copper, you can find copper, FR4, that's there. So yes, um, what else here? Okay, and once you're done, oh, you can assign, choose the, change the color from here. These are some things here, and you had a tree here, I mean, tree of command things in the case of CST. A little bit of different in this zone. However, this is not difficult. I mean, um, uh, we, we just mentioned about that attribute and command box. Still, you can change here. In the case of CST, we had that at the below of the workspace. Remember, um, where you can put the parameter things and other things. We're having in the case of HFSS, we are having this here. Okay. All right. So I think we have covered already these things. Um, the dimension, X size, Y size, and Z size. Sign material, we've done that already. Um, okay, so this is about these three things. That's the one. If you just click on that thing and delete or edit or whatever it is you can do, just click on that box. Okay, if you want to edit, you can edit, so on and so forth. Okay, so assign material. All right. Okay, so excuse me. I think we have already covered those things. So just a little bit of assignment here. Create the objects specified in table 1 and keep a record of them in your logbook. Okay. So you have to build up some different objects such as a sphere, brick, and cylinder. Uh, you have to do some specific material for each of the objects, and you have to do some specific dimensions. So let's give it a try. Okay. If you're just stuck, you can just let me know. Okay. So yeah, all these things are, you can find it here. The cylinder, that's the brick, and that's the sphere. All right. Okay, let's move on. Now let's talk about some interaction. Well, um, not pretty much to mention here. It's just all about how you will be moving your stuff here. Okay. Uh, well, you see this section here actually. That's for interaction. So, for example, if you want to rotate, just click on that thing. There we go. Okay. And I think this interaction, that is, I like this interaction most. Anyway, it depends. You see the pen. If you want to put that right in the middle, just click on Orient. If you want to zoom in, zoom out, that's it. So that's all about interaction. Um, what else here is, okay. Okay, remember the one of the very overused, I mean, not overused, I'm sorry, very widely used function called pick function. Okay, you need that a lot in the case of CST. In the case of HFSS, we call this select function here. Okay, so for example, if you wanna, you see this box here, if you wanna pick any face from this box, just click on face. Okay, now it will not work because you see the cursor, we are still in the mode of uh, interaction things. Just press and escape unless or until you see this arrow sign. So sometimes we just get confused why it's not working. In that case, escape is one of the great button, okay, to return to the previous stage, normal stage. So yeah, I mean, unless or until you see this, as I'm hovering, as you see the mouse, just click on escape, and you are sort of in a reset form, and then press face again, face. You see, whichever the things you are clicking on, it's just being clicked. Okay, so if you wanna pick another face on the other side, well, you cannot do that, can you? No, you can. In that case, you have to come back to this interconnection. I'm sorry, interaction, and just rotate the things, press escape, and again go to face or go to edge. Let's say if you want to choose an edge, you see, there you go. So that's sort of a pick function, but remember this is really important because sometimes you want to construct something else right along the edge. in that case you have to use this function exclude pretty much. So yeah, so press escape, you're done. And well, so yeah, nothing pretty much. The select function. So yeah, let's move on. Okay, the coordinate systems, just similar to CST, we're having global and local. However, we're having some different names. For global, we will call, in the case of HFSS, we'll call this absolute coordinate system. And for the local, we'll call this relative coordinate systems. And excuse me. And if you know the purpose of these different coordinate systems from your previous tutorial on CST, uh, I would like to say that they're both same. They're having same purposes, same uses. Okay. However, let's have a look here. We are having a little bit different interfaces here. Um, if you click on a box and you hover your mouse, you see, uh, just look at these values x, y, and z. You see the changes. Let's say this is an origin, and so that's 0, 0, 0. And so if you want to construct something here, first you have to start with the coordinate, absolute coordinate system. For example, if you want to design something here at the corner, okay, let's design on this something. So now you're you're done with the absolute coordinate system. And if you want to manually put a point here, or we are not doing that manually completely, but now you're in the relative coordinate system. Okay, since you have already chosen the absolute coordinate system, based on that absolute coordinate system, you are now designing, you are putting all the points of that particular box in reference to that absolute coordinate system, which you can call now relative coordinate system. And that is what is happening here. Okay, so yep, so you have construct a box here. Now if you wanna, for example, as you have done with this design, if you wanna, let's say this is an important feature here, which is page number 12. uh, you would like to define a sphere with a center located at one of the top corners of this cube. Okay, this is very important, and this is something that you I mean normally whenever we are designing some complicated things, so we might have to, for example, if we that could be, there could be different layers of boxes or different and in that boxes there could be some cylindrical things, cylindrical shapes, or sphere shapes or circular shapes. So sometimes we, I mean, it's really hard to trace actually the global coordinate system. So, and every time if you want to define the global coordinate system, this is going to be really difficult for you. So let's say you want to put something right at the corner. Okay, in that case, the relative coordinate system is pretty handy for you. Okay, so uh, let's do some examples here. Let's say if you want to define a sphere with a center located at on one of the top corners of this cube. This is, we're going to put it here. Okay, we're going to put it here at the top at the corner. So go to modeler, coordinate system, create relative offset. So click on that thing. There you go. So whatever the things you will be building from now on, that will be built based on that point. Okay, this point. Okay, so let's try something else here. Let's try another box. If you can start from anywhere, but remember we have chosen these points. That's why the pointer is being changed. Here we go. So yes. Okay, so you might need this feature at different points whenever you will be designing some complicated design, maybe, or let's say you wanna design, you wanna choose this point here. So go to modular again, coordinate system, set working coordinate system or relative offset. Choose this point. There you go. So basically, what's happening now? You see this box. Click on this box. Box one, box two, and sphere. So basically, the sphere is centered at that particular point. Okay. So this is how the relative coordinate system works. Okay. All right. You can try more shapes if you like, for your interest, and that will be really handy for you. Okay. So we're done to this point. Shown this. That's they have created the tutorial has created the box first and chosen this point as relative coordinate system, and then put our sphere on that thing. All right. All right. So now let's move on with some uh, operations. From CST, you know already what is the functions of those operation things. If you want to move a shape, if you want to copy a shape and move, if you want to mirror the thing, rotate the things, if you want to make it larger or smaller, um, you have learned that. I'm assuming you have learned that already from the CST, um, and those are really important features uh, if you want to design something using CST and HFSS both. So there could be some, for example, if you want to make something, let's say you're having just one box, but there could be situation that on a plane, let's say on this plane, if you just select these things, um, and on this face you want to put multiple things. Let's say one, you want to put one another box, or maybe one ring, two rings, three rings, and many more. Well, it's not worth it to make that particular or individual um, ring every time. Well, you are not going to be finishing your design, never. So that's the thing. That is what you will be required. I mean, that is. I mean, these kind of functions, these things will be required. It will be really helpful in those situations. You might have to design a very big thing with multiple things in it. Okay. Yeah, you might need to duplicate. You might need to make it larger or smaller. So let's play with these things. And also, this is pretty straightforward and pretty much similar to CST. However, uh, you see some different names called arrange, duplicate, scale, um, or maybe not, but rotate with. So let's try some. Okay, let's try some. Let's try with move first. Uh, for example, if you wanna move this sphere, you see. Well, I'm not sure what the tutorial says. It says uh, basically. Okay, I mean, you can just go straight from here. All right, so let's move. See, so just click on that thing if you want to move this way or that way. There we go. Okay, so it's just moving. Um, all right, and go rotate. If you want to rotate, again, I think you've seen here. Well, you don't understand if you're reading this thing, but let's try these things. There you go. Oh, okay, sorry. Um, the axis you want to rotate around. Let's keep it default. When I put this, let's say, to make it more visible, let's choose 45. Okay. Okay. Since this is a sphere, it's really hard to say. See that thing? Let's try something else. Okay. One thing just to let you know that although you're having all these functionalities or tabs is here, you can try from here as well. Um, if you click on edit, smooth, rotate, mirror, but uh, I think I feel more handy when I'm picking up this function from here rather than going to the edit tab. All right, so where we were um, trying the rotating function here, just select any object, click on rotate. Okay, so if you want to rotate around the z-axis, well, you can do that. If you want to rotate that by 45 degree or any other degree that you like. So nothing more here. So that's all about rotating function. Let's look at mirror function. You have to for a mirror function you have to choose an axis or a reflector that will act as a reflector. So we are mirroring this small brick, rectangular brick. Let's put it here along this axis, and there you go. So you see, whichever the direction you are moving, your reference axis, basically you are just reflecting this particular break in that direction, and you see all the parameters are changing here as you move the things up here. Okay, so this will be actually rotating around the z-axis. I'm sorry, the axis that you are actually selecting through your mouse. You see that, right? So you see that little tiny things, one coordinate system, and that is your reference coordinate system based on which you're actually mirroring this object. Okay. If you go to if you want to explore more things such as scaling the things, well, scaling means um, increasing the numbers. You might not find the things here, the scaling. However, you can go to edit function and scale. So basically is here. You see that some other options here, set along line, round axis, and through mirror. So those are the scaling function. However, you will not find straight away the scale function in here. So don't avoid to avoid the confusion. You might ignore that term scaling. Rather, you can focus on these things. So if you remember when you are using the CST, um, you put some numbers along some axis, for example, like this. Let's say here more. So yeah, there we go. You're copying. So I think you are familiar with this function if you have done the CST already, right? Okay, so if you wanna copy the things, um, we wanna copy these things here, or maybe choose the sphere right in the middle. And if you are two, or maybe just select this box, not the line. If you wanna do something like this around the axis, that means imagine this is the axis. So if you just you see, um, let's make it 45 degree. So that means we're actually, so what you are doing here is you're just rotating along this axis. So basically, and they're 45 degree apart from each other. So very handy things when you are actually designing something really complicated with multiple elements in it. You are just you want to avoid the tedious approach. Okay, so I'm not um, digging these things really into deep, because the first thing is that you have you are a little bit of familiarized with these sort of functions as you have come across CST. And number two things is that uh, this require more practice to implement all this functionality rather than just showing up them here. And there'll be, I mean, well, um, if you don't face the problems while you'll be designing, and if you don't face the necessity that you need some multiple elements, you will get to know. You will not uh, be able to learn much about these things. So I strongly recommend that just play with the shapes, design yourselves some random shapes, maybe some random design. Only then that'll be really handy for you, and you'll be more confident about those things. Okay, right. So let's move on. Okay. Um, Duplicate means copying. Okay, we already have seen that. Basically, we've already covered that anyway. So we have seen the duplicate along the line. That means if you want to copy, you have along the line. If you want to copy around the axis, some incremental step in terms of degrees, and then again, just you might want to explore more if you would like to learn more. That is what I think. All right, so there are more operations. You see the Boolean things. Well, if you remember that if you want to unite two shapes or subtract one shape from another, so these kind of things are done by the operation called Boolean. This is pretty much similar that what you have done to that. you have done in the case of CST. So let's have a look a little bit of things. For example, um, okay, we have something here, both shapes. So on a sphere, see there are some um, common section between them. So maybe we can try both shapes here. Okay. Right. So let's choose this and that. So these are the things you see. All these things are Boolean. So if you want to try the Boolean unite, now you can see that they are actually united. So it's one into another. And if you wanna, let's try this. Sorry. Okay. So let's try this sphere. Um, with this one. What would happen if we press this part? So numbers, first. I think you got it. So we have just subtracted from the sphere from the box. This is how actually you have to just kind of have it having some trial and error and play with more shapes. And so let's not um, be too much elaborating on these things. I'm assuming that you should be able to play some more, play more and learn more about these operations, because there is, uh, in fact, this is limitless. It completely depends on the things that you will be designing particularly. So um, that'd be great if you just try yourself more designs and you'll be more expert in this part of this tutorial. But I can assure you that if you know more and more about, especially these operations, such as we have the Boolean parts and also excuse me, duplication, scaling things, translating the things, uh, you'll be more confident in the software as a whole, and you'll be able to design more complicated things with the software. So I strongly recommend, please um, do your part. I mean, play with more shapes and designs. If you really want to do some designs and if you want to learn this software more and more, that'd be great advantage for you. All right, so okay, just at the part that there are some exercises for you. Okay, just read those and try to answer. As I said, that you need more practice on those things if you want to be really experienced, and if you want to learn more about these operations. So yeah, and the design things. So these questions, I'm expecting this will be submitted in your lab report. However, again, I'm not being so hard that you got to be 100% correct. So I'm not being like that. So just if you are stuck, if you need some help, uh, you can just email me anytime. Okay, and I'll try my best to answer those and clarify those things for you. Okay, all right. I think we have covered something like this. That if you wanna, this is a face selection, for example. If you wanna face something at the top of it, for example, if you wanna, we have shown this, we have shown that previously. That let's assume this is one break. Okay, let's choose this break, or just unselect this. So if you want to put something on the top, or maybe at the bottom, That means you have to select this face, and and you have to, if you want to select something out of this face, there is another option called modular. Go face, modular surface. Go. Let's give you a moment. Oh, okay. Oops, sorry. So that means you have to choose the face first, this one, and then go to modular, go to surface, create objects from face. There you go. So now, if you wanna, this is pretty much similar when we were talking about the relative uh, coordinate system. Remember, in previously we have talked about that uh, we selected on the top, we selected one corner, which is the new origin or relative coordinates, coordinates where actually you have put a sphere with the center on it. Remember, this is kind of the same thing. Uh, Actually, here you are now. The coordinate system has been shifted to along this surface, or and where you can put another break. Let's say, you know, so you just put another break, okay, on the top of their surface, out of their surface. So yeah, now I think you should understand that this is a little bit of similar thing when we are talking about the coordinate system in some points. This is, for example, in well, let's talk about these things here. This is a very familiar structure of microstrip patch antenna. Well, we'll be talking about that thing a lot in our coming labs. So microstrip patch antenna or any antenna, uh, if you talk about an antenna, uh, there are some layers which looks like this. There is a ground layer under a dielectric layer, which is, let's assume for a while, this is the green part is the dielectric layer, and underneath, uh, with the same dimension, just except the thickness, we are having a ground layer. Okay, so let's talk about it in the context of this. Let's say this there are two layers here. Although this is a very unusually thick structure compared to an antenna, however, just for the sake of an example, this is the dielectric layer, and underneath there could be ground layer. So when actually you are designing a thing with multiple layers, in that case, this operation can be really handy. Okay, so yeah, um, and you might find like actually three layers. It's a ground, then there is a dielectric layer, and on the top the copper layer, or the main radiator where actually the radiation will take place. Okay, so yeah, let's move on. Okay, so I think you know something about boundaries, which is really important feature in any electromagnetic design. Um, as basically this is required um, in this kind of simulation software. This is one way that you are just defining the confinement of the solution whenever you are running a solution, running the simulation for a particular design. Um, as you know that the HFSS runs on a method called finite element method. Um, so this is just you are actually making a confinement, or you are just defining the simulation area, or you are just defining the number of meshes around the design up to which the simulation will uh, conduct the calculations and give you the result. Otherwise, well, we don't expect an infinite solution or infinitesimal behavior of any software. So basically, in a nutshell, you are just confining the uh, area of the simulation, or you are just imposing some boundary con- boundary boundaries for the calculation process. So basically, there could be like two types: open boundary and closed boundary. If you talk about the waveguide or coax cable, those are surrounded by some shielding, or surrounded by some coverings. That means the EM wave can propagate through those waveguide or coax cable, rather than just the radiation is not going away from the confinement. So in that case, we can, whenever we'll be running the simulation for those kind of structures, that would be a closed boundary simulation. And if you talk about the open boundary, let's talk about antennas. So if you're just posing the very close boundary situation, in that case, let's say perfect electric conductor, in that case, the radiation will not be released from the confinement. That means, which is a not favorable condition for the antenna. So in that case, for an antenna, normally we run an open boundary condition model. So let's get into the software a little bit to show something. For example, we have assume we have already put a box, which is our design. For the sake of understanding, let's assume this is our design. So if you wanna create a boundary uh, here, uh, and you wanna put that design inside the boundary, let's create a box here. So go to create box. Uh, Go to, let's follow this tutorial here. So create open region, which you can find from the HFSS. Then go to model. So this is something, okay, if you want to put the frequency here, you can put. For now, we are putting that default radiation. Let's assume we are designing an antenna. So frequency, let's say, is 1 gigahertz. So press OK. So actually, we have just built a box around it. Okay, just the box here. Um, yeah, let's delete this here. Okay, so just for now, you see that the box around, which is a geometric box. Uh, so before you assign any boundary, you have to create the box first from HFSS model and create open region. You see the very tiny design things here. One thing to mention here, uh, it doesn't always. It is not always the case that you have to put the box, or you have to put your antenna or resonator or whatever it is you are designing right in the boundary. Well, the whole things could be in the boundary, or or that can be partially within the boundary or partially out of the boundary. It depends on the situation. It depends on the outcome that we are looking for. So for now, assume this is the design, which is a box, and around the box we have created a geometric box, a frame, using this HFSS model and create an open region. All right. So after that, uh, let's go to this tree, the tree commanding region. I mean this window, sub window here, and go to boundary. So if you want to create or assign a boundary, just go assign. Let's say you want to create a radiation boundary. Sorry, maybe we have to click the box first, because this is looking for the box first. Okay, and then uh, click on right click on that thing and then assign. Sorry, something's going on here. Sorry, yeah, click on that thing. Yeah, not here. Click on the this this heading here, not the subheading. So and then you should go, should work now. Okay, so here we go. It's looking for a name. Just keep as it is here, and then press OK. And that's the thing. So this is your boundary, uh, which is a radiation boundary, or you can create. Let's say if you wanna reassign, again create this thing. You have to create the geometric box first. Otherwise, whenever if you wanna assign the boundaries without selecting the box which you have already created, it will not uh, find any structure on which the boundary would be created. Okay, so now that we have selected the box, and if you want to reassign the things, or if you want to change the type of the boundary, let's say you want to make it perfect electric boundaries or perfect magnetic boundary or anything else, just click on that thing. Okay, so it's changing the type of the boundaries. Well, it's really hard to explain here in detail what kind of boundaries will be required for what problems, because it's complete, that completely depends on the type of the design, or uh, or the type of the outcomes that we are looking for. Okay, type of the scenario, circumstances. So maybe if you wanna, again, I strongly recommend design something in your interest, and you will get to know better. So this is not the end. You should practice. You should continue practice. Maybe there are a lot of tutorials from YouTube, from internet, so you can have a lot of accesses to them. Okay, that would be really great if you just practice, and you'll get to know better and better. Okay, so yeah, that's something about the boundaries in short. Uh, Again, just the purpose of this boundary, as I mentioned, that you see, it looks like something. There are some patterns look like it's a box. You don't see the design inside, but there is the design. Okay, um, so basically now what's happening here? Uh, you were running the simulation for the HFSS is running for the simulation for this design. Um, um, the technique is finite element method, or and for that, well, that technique is being applied not everywhere. Rather, the calculation region basically is happening along, I mean, within this box. And these patterns are sort of a representation of the meshes within these boxes. Okay, and I think we talked about meshes before, and you know that meshes before from CST as well. So once the simulation, so boundary setup is done, um, we can move on to the solution setup section. For these, I have I have opened up a pre-designed microstrip patch antenna, because um, there should be some features would be unavailable, and in the simulation setup, if I'm not done with a complete design with setting up the ports and setting up the boundary conditions. Um, Okay, so that's why I've just opened up a pre-designed microstrip patch antenna where I've done the boundary setup already. So let's move on to the simulation things. Well, um, probably I didn't mention about, we did mention about these tabs here. There are so many options here. Probably I didn't mention about these tabs as well, where you can get many things, get to, you can go to many options very easily. So yeah, since if you just click on that model thing, you can draw, you can just get those things back. Uh, so my preferred way is to get to the simulation part by clicking on this. Pretty easy, and you can see all kind of simulation setup things such as mesh setup things. And there are more setup things, frequency sweep, and validation, and analyzing the all things. Okay, so well, we are not doing anything with this mesh setup. We just keep as it is. I think you already know what that mesh setup means. So click on OK. We don't need to look into these things. Let's go to the frequency setup here. Okay, so go to advanced things. Although I have already uh, set up something already for that can run the simulation. But however, let me show you that again one more time. So click on that setup thing, go to advanced. Let's say my particularly this antenna will be operating at 2.4 gigahertz. So our frequency of interest is 2.4 gigahertz. Um, well, you really don't want to change those kind of things, so we'll just keep as it is. Let's click on OK, and then let's close this now. We'll go to that manually. This is talking about uh, frequency. I mean, at solution setup. I mean, at frequency sweep. Okay, one thing. Well, I'm not being pretty much stick to the tutorial here because of this tutorial was made in the context of a different version of HFSS, which you might not get exactly the similar thing that is explained in the tutorial. So you can still get to that, but the, I recommend that you just follow. I mean, make the things pretty easy. So just follow what I do here, and you can reach to that very last command, which is add frequency setup. So again, um, we will look at these tabs and we'll go to the simulation here. Then you don't need to click on those mesh setup things. This is default, and you just click on the setup things we have, which already we have seen here. So let's do that again. It's 2.4. Let's not do that. You will do that because we are setting multiple setups here. However, you can still do that. So you can actually, the analysis can have multiple setups here, but already we have done many because we are trying to show you multiple times. So once you're done, then go to the frequency sweep, and this is really important, that at frequency sweep, the always try to choose. This is how the graph would be generated once the simulation is done. Graph means the S parameter graph, which you have already seen in CST. Okay, you will see some similar types of results here. So let's change. I mean, you can change anything you like. Normally, we keep that as fast, and since our center frequency or the operating frequency is 2.4 gigahertz, we would be somewhere around there. So this 1.2 gigahertz and 3.6 gigahertz is the range. Definitely 2.4 gigahertz falls into between those two start and end frequency. This is kind of a like the range of the frequency where the data would be plotted. You can change here sometimes if you don't wanna see that. You can change. If you let's go to linear step. In that case, this is how you would want, I mean, the gap between the points, which is 0.006 gigahertz. Well, the smaller, the finer. That's pretty simple. If you want to make some big jump, maybe you have to increase this value. Okay. So yes, nothing special here, and just press OK. And once you are done, okay, let's go. Let's move on. I mean, let's move to the next step. We have to. Well, there are some things at this point I'd like to mention. You haven't seen the next options or something like this in the case of CST. For example, it's validation. The design needs to be validated. Okay, so once you click on that validate, just click on the validate, and the, if you see all the tick marks, um, you can assume that design is validated. Design is okay to go for the simulations stage, and that's it done. And click on that analyze all, and that's it. So basically, the simulation is running on anyway. But the thing is that you see there are messages here. Let's see this message because simulation didn't run. Let's see what are the messages here. So it's all about licensing error. So that means this particular HFSS has got some licensing problems. I don't know what it is. Maybe I will figure that out. But because of the licensing issues, the simulation has stopped. It didn't run. But anyway, let's assume it has run. But that's it. You will get to those results straight away, such as S parameter and other things. So I think that's it. Maybe I mean it's just the basic things, and I'm not being so much detailed on the things. We are not doing any other designs on the HFSS, but I strongly recommend if you wanna learn something about another software besides CST, that would be great for you. Uh, so yeah, I mean, still, we can just stop here. But still, if you are having any issues, whatever the things you are doing with HFSS and designs and other things, please feel free to email me, and we can talk and discuss on those things, and we can get these things resolved. Okay. So yeah, that's it. Thank you.